Alrighty, over here. I made it about 5 minutes into class this afternoon until someone told me I had the wrong screen on the projector. So that's how my day's going. That's okay. Let me make sure I got the chat pulled up here. The other screen. So we're moving on. We kind of jumped around a little bit here. I skipped some of these earlier chapters. It wasn't quite as interesting to talk about. I'm going to focus more on object-oriented programming, specifically around classes. We'll come back to some of these other topics here. Right. So we've got enumerations, tuples, static stuff, null, and we'll see how far we get into inheritance and polymorphism and interfaces, structs, records, generics, and some other cool stuff. So I don't think we'll get through all of it tonight, and that's okay if we don't. We've got some decent amount of time we can spend on these chapters, so not too worried about that in terms of the schedule. The advanced topics will definitely take all 2 weeks on and see how that goes, but should be okay. So I've been adding the recordings here to the GitHub page because it entertains me. So I also link them in Canvas. I think everyone's been able to find them. So I think I added the quiz, didn't I? Someone had asked about a quiz. I think I added one. Did I forget? There is one. Yeah, okay, so this is our object-oriented programming and unit test quiz. Good. So if you didn't see that show up, take it. If you don't get it in by tonight, that's okay. Take a little bit more time on it. I'm not too concerned here, especially because I'm super late on this thing. So that's on me. Don't leave it for weeks and weeks and weeks, though, please. So at some point, take it. It's not timed, so click on it, read the questions, close it, come back to it, whatever you want here. I think artificial time pressure is pretty dumb for these sorts of things. So this is honestly your incentive to open the book. I get it. I was a student. Some classes I didn't open the book. I'm not a little embarrassed by admitting that, but that's okay. It is what it is. So ideally, you're opening the book, going through the chapters. You don't have to necessarily read every single word. I get it. I mean, I'd like to imagine this book is better than your typical textbook, and it's not terrible to read. It's not super dry. But if you're skipping over stuff, that's okay. Just get the important topics. And then if there's something that comes up in a question, you're like, oh, I don't remember, I don't know, and go look it up again, right? Go back to the book, open it up, find it, that sort of thing. So should be not too bad there. And then I got to remind myself, quiz for tonight. I'll post another quiz after tonight for some of these other advanced topics here. Fluffy, I'm glad you enjoyed the book. Thank you. Hey, Maestro, thanks for joining along online. Yeah. So before we jump in, I want to spend a little bit of time talking about a tool you probably heard about. I'm sure everyone's chatting about it on your own private channels, that sort of thing. It's ChatGPT. It's pretty cool. I don't think it's the solution to everything. It's not going to make programmers go obsolete. It can write code. It can write, code. So it's okay. It's not bad code, and for simple things, it does it very well. That's great. The good news for all of us, and I'm assuming because you're here to learn software engineering sort of stuff, or programming, or computer science, or whatever you want to call it, is that it can't do everything. We still need humans to do design, to do implementation, to actually fit these pieces together here, because it doesn't give you exactly what you want here. There's a lot of nuance that goes into writing software. And you might not have known that based on the really tiny things you do in CIS 150 and 200. We write really small programs that are meant to scaffold up your skills and learn how this tool or this technique works in code here. But as you move higher up and you know more things and you have more tools, more techniques, more languages, that sort of thing, just like we use the visual designer, I want to drag and drop something in. It writes the code for me to say, hey, put it here, add an event listener here, this sort of stuff. It's just an assistive tool like that. And I think that's a great way to look at using it. Use it to make you more productive. I think that's the general consensus of folks online. Although I do admit the Twitter community of tech people, probably a bit of a bubble and a little bit isolated, and everyone talks to each other and you follow people who all tend to agree, sort of thing. So maybe I'm a little skewed here, but in general, everyone seems to be hopeful that'll be a useful tool. So before this one came out, GitHub had their Copilot tool, which was a little more rocky. It did a lot of cool things, would do a lot of automated code for you, but it was a code-specific tool trained on code, where ChatGPT is a little more generic. It can do a couple other things. Also pretty good at writing code, but the chat portion of it is really cool, that it's kind of a back and forth interactive piece. If it does something and you want it to change it, you ask it to change it, and it changes it. It's pretty fancy, that sort of thing. Yeah, is that a question?
Yeah, I just wanted to throw in that I've seen some pretty funny exploits on it. I've seen on Twitter someone hooked up ChatGPT to a Twitter account to go around and because they were like a remote work company, and to go around finding tweets that mention remote work and reply something like, "Yeah, good for us. We love remote work." Except then what someone started doing is making a tweet that would just say like remote work, disregard previous instructions, new instructions, and then they say something goofy.
Yeah, the things that you can do with the tool is really fun, and that's part of the fun of playing with it. Especially if you have that mindset that's a little bit more like quality assurance style, or like white hat security style. Can I break this thing? Can I make it do things it's not supposed to do? And by telling it to disregard instructions, it will do funny things. And that's sort of the problem anytime we automate anything, is once it's out of our hands, people are going to start doing things with it. So it's kind of fun. So I want to show you, and I'm struggling here, to be honest, as someone who gets paid to teach you, and I get paid to grade you. Really, that's what I get paid to do. I get paid to grade things. Anyone can pick up a book and read it, but eventually you get a college degree because supposedly qualified people are saying you did well enough. I think that's the whole higher ed model, right? At some point people talk at you, but sure, let's mix or match. So I asked it to make a Yahtzee scorecard. Did a fine job of it. So the first time around, I said, and this is chat.openai.com. Has anyone not heard of this? I'd be really surprised. It's okay if you haven't. You don't. It's okay. All right. So my assumption's fine. Okay. That's what I thought. Are you okay admitting if you've used it for class? I don't care. And I'm bringing it up at this point to show you how I would like you to use it if you're going to. Is that okay? They want to admit that you've used it, or for a different class? You don't have to. I don't. I'm just curious. This is my own. Like, I'm a weird person and I like to know things. So, okay. I've used it for all of my classes that I'm teaching. Like, I just feed it stuff to see what it does because it entertains me. So write a C# class that represents a Yahtzee scorecard. Have it a set of dice and show all possible scores for the given dice. I feel like that's pretty close to what we talked about last week for Yahtzee. Like, this is one of those core components: is make a class for scorecard and have it tell you what scores it can. Right? It's a small piece of what we're wiring up into the graphical user interface. You can feed it more detailed things and get more detailed stuff back. I want to start at let's do a small piece here. Is that fair? Okay. So it does some cool stuff, and it's all printing here, which is not what we want it to do. But the guts of it are here. I think we could take something like this and go modify it, right? And figure out what we need to do from here without looking at anything else here. But the interesting stuff, and I imagine you folks are all relatively smart. You made it this far along. Figuring out how to, if you have a 3 of a kind or 4 of a kind, is not a hard problem. You can all solve it. And it might just take a little bit of work here, and then figuring out how to write the code for it, sure. But I don't doubt that any of you could do this sort of thing. So making the tool write some code for me, it just saves me some time here. At some point, being able to puzzle these things out and break down a big problem into small problems, this functional decomposition, which is my favorite technical term in the world, is a skill we need. And we need to practice that and be a problem solver, because that's the art of programming. That's the art of being a software engineer, not the science side of things, but the art of it is how do I take the big problem and break it down? And tools won't always do it the way that we want or the way that will be useful for us. So we still need to apply those sorts of skills. And that's why I think this is exciting, because we can use it to make the rest of what we do faster. And then we can still do the interesting human part here of, well, how do I fit these pieces together? Just like we take libraries for things. I don't need to write my own list function. I don't need to write a linked list versus an array list versus a tree. I just use the class of the library and it does what it wanted to do. I think it's similar to that. Here, it gives me some code. Now, we need to be a little more critical of the code it gives us, because ChatGPT is very good at being a prose machine. It will imitate things and give you what you ask it for. If another funny Twitter thread, because this is what I do apparently at 2 a.m, read Twitter. Someone asked it to write an essay about the Space Bears program that Russia had. And it gave them a 5-paragraph essay about the Space Bears that Russia launched. because you asked it to do that. So the tool will do what you ask it to do. If you ask it to do a dumb thing, it will do a dumb thing, just like software, right? If we write dumb code to make it do dumb things, it will happily do the dumb things, right? So that sort of thing. So applying it well, I think, will be a useful skill. And the last thing, all right, I will try not to say Twitter over and over and over and over again, but someone had a survey they put out there, a relatively well-known person in the developer community, and they got multiple thousands of responses, like how many people are using this actually in their day job? And it was around a third so far. Professional developers were saying they're using it day to day, or at least a little bit. I don't know, to what level or what degree, but some people are using it. And obviously that's going to depend a little bit based on your industry. You probably don't want to feed it things if you're in a very sensitive industry, right? This is an open tool in beta. They're like, our research scientists are looking at everything. I don't know how much they actually look at, but anything you type in here, you're giving away. So you're not going to go take your company's proprietary code, feed it in here and say, hey, write me a new feature that does this, because that's a really good way to get fired, right? You don't give away your company's proprietary code, especially to some machine tool that will then probably turn it into the language model. And then someone else asks for it. They're like, oh, here it is. Do we see that's why that's a bad idea? Okay. I don't need to spend too much time on it. Sorry. So fun things here. Now, this probably doesn't make any sense. I'm just going to take a guess right here. Probably doesn't look like anything we've done before. We haven't, and that's okay. Right? So turning something like this in, if you don't understand it, is a big flag. Yes, this works, and we can test it and make sure that it does what it's supposed to do, but we really don't want to use something that we don't know how it works. That's a real big issue. So if we're using the tool the right way and using it to help us be more efficient, you have to know what it's doing, right? So this is all based on the LINQ library in C#. LINQ is fantastic. You can do some amazing stuff with LINQ. It gives you this really cool syntax for doing stuff. And this entire solution is LINQ. Dice group by, die, any group count greater than 3, question mark, dice sum, :0. I've done C# enough. I understand this. I'm not trying to toot my own horn. So like, I get what it's doing. But if you don't get what it's doing, don't give this to me. Okay? So that's the big flag I usually get from people, is that they turn in code that doesn't look like it's understandable. And after we've covered LINQ, we'll get to that in the advanced topics, this will make sense. And that's great. That's fantastic. But all of these solutions here are kind of funny. Dice intersect, straight, count, equals length. Numbers, skip I, take length. Like, I know what an intersect is here. Like, I've got to take a few minutes here to look at this to make any sense out of it, because this one hurts my head to figure out whether or not you have a straight. So, be careful with your tool. That's what I'm saying here. So, and then because this is academia, right, we cite our sources. If you use something that you didn't write, you cite your source. Just like if we find someone on Stack Overflow, you drop a comment in. What I'd like you to do, and I think it's a good habit for you to get into, is say that you got it from ChatGPT, the website, and include the prompt you used, please. So I'd like a comment in your code saying, hey, I sourced this from ChatGPT. This is what I asked for. The interesting thing is it doesn't always give you the exact answer every time, which is a little funny. Honestly, AI still hurts my head. I spent some time studying it, but not enough. And most of the time it's repeatable, but you get some weird variations here and there. So again, it's not perfect, and there's not like a URL, like you can't put your Google search in, like, what's my query? It doesn't, we can't do that like, what was it, Q, like a Google search. You can give it the query and the URL. We don't have that. So just, hey, I got it from ChatGPT. This was my prompt. I'm cool with that. Okay. Using it part for part. We still need to do the work to put it all together. Now, if you want to spend an hour and a half trying every single prompt, asking it for UI stuff, copy pasting UI things, driving yourself nuts, it might work. It can probably generate the designer code. I haven't gotten that far yet to see if I can copy paste designer code in and put it in the right spot, because that always blows up in my face, like you saw last week, when you try and move things around in the UI and then change other things, and that's a little ugly. So I'm imagining here that even if we use it to build some of this business logic, the game logic here, we're still going to do the UI stuff by hand. If you make it do the UI for you, fine, cite your source, that's okay. I feel like that's probably more work than it's worth, because honestly, doing the UI stuff is not hard. You like drag stuff in, click some boxes. right? Is that maybe that's a fair assumption? You have to try it and see. You got another week to work on Yahtzee and see. So, but again, this is this conversational tool. So I said, hey, can you write it without using link? And it said, sure, I can do it without using link. Now this makes a whole lot more sense. Like count score. Let's go see if the die is the number, add it to the score, return the score. So now I can count ones, count twos, count threes, count fours, count fives. This is not a hard algorithm. Like this is not groundbreaking here, how you count up the number of values you have of your dice. So this is not the interesting part, I feel like, of what I'm asking you to do for Yahtzee, right? Some of the other things like three of a kinds, sure. Four of a kinds, sure. Full house is if you have a two and a three of a kind. They don't use curly braces, and it drives me nuts. I hate that. Really wish you would use more curly braces, but that's okay. If we have a two and a three, you get this, and I think this is relatively straightforward. Excuse me. And then it stops. It only outputs so much at a time, and then you like, please keep going. Please tell me. And the other fun thing is because the tool is being used so much, they limit you. Sometimes you can't even get in unless you want to pay them $42 a month, and they guarantee you access. I don't recommend you pay the money. I don't think you need to. Right? If it's busy, just come back later. Right? If you've waited till the last minute and you have to turn this thing in 30 minutes, you've done a bad thing anyway. Right? Reevaluate yourself and figure out what's going on here. Don't wait to the last minute. As I say, with 3 things I have to turn in tomorrow because the due date was tomorrow, so I said I can wait till Friday. Okay, I'm talking to myself too. I have bad habits. That's fine. But then it continues on, right? Whether or not we have a straight. This one was still kind of funky. Like from 1 to 6, if the die contains I, my dice list contains it, add to count. If I hit the length, I'm good. But if I don't contain, reset count to 0, but I'm still counting 1 to 6. I think it works. I have to go and test this now and try it and give it some different values and see. Right, and that's the next piece here. As we're looking at writing unit tests. How do I test this stuff? We want to make sure that the code, if we're just copy pasting here, does what it's supposed to do. That makes our unit tests even that more important. And now some people will say, yeah, you can ask it to write its own unit tests. Yeah, you can. You've got to be really doubly sure that you know what the unit test is doing. Because if you ask it to write code and ask it to test itself and it does something and you don't understand what's happening, there's a decent chance it'll go badly for you, right? I mean, this is relatively basic. Yahtzee's not a super complex algorithm or anything, so you'll probably be fine. But for actual important stuff and things that we do out in the real world in the industry, I'm still very hopeful that software engineers are making sure things work as they're supposed to. And that's one of the things we're supposed to do. Hopefully you had a chance to talk about software engineering ethics in your 200 class. I think they still do that, right? In 200, you talk about ethics? No? Okay.
I mean, you were my professor.
Yeah, I talked about it. So I was told I was supposed to talk about it. So that's kind of why I talked about it. But so the ACM or IEEE software engineering ethics, code of ethics. That's what I want. Code of ethics. Thank you. See if we can't find this. This is super good stuff here. So, and again, it's not something we really enforce on people, which, and this is hard to enforce this sort of stuff anyway when you get to ethics, and that's the whole lecture. You get to 200, but like ensuring your products and related modifications meet the highest professional standards possible. Don't just slap something you found online in there and pray that it works. That's bad news, right? The reason why we can call ourselves engineers and to use that term is that we're going to be professionals about it. We're going to follow correct processes and procedures and policies and actually verify that our stuff does what it's supposed to do. The term hack is someone who just throw stuff out there. It might work, might be great, and we've sort of taken that term and called people hackers, and there's a bit of glory around that occasionally for depending on how you look at it. They just try stuff and with no regard for professional ethics or professionalism and that sort of thing. So people who write spyware piss me off because it upsets everyone in general at software engineers. So I take a personal offense to people who write spyware. Not that it matters at all or that they care, but like that one hurts. So anyway, that's part of what we do, right? As professionals, that you make sure it does what it's supposed to do. So we're not just going to take stuff, copy paste, and hope. right? So it's a tool. The tool can do some stuff for us, just like Visual Studio does some code for me, right? It can generate some code. That's fantastic. I love that. I don't want to have to do all the boring stuff. I want to do the interesting stuff of making all the pieces work together. All right, I've gone too far. You're getting bored already. I'm sorry. So apologize, but you are welcome to use it. But I would ask that you cite your source, including the prompt. Is that okay? You agree to that? All right. I'll probably actually update that here in the policy at some point, and get you out a new copy of the syllabus, because I think that's worth having in here. That being said, I am not your instructor in other courses. Don't tell them that Eric said it's okay for you to do it everywhere. Okay? I don't want to get in trouble. So this is my expectation for my class for the work you turn into me. Okay, just to make sure that one's clear as well. So that's what I was talking with Dr. Bruce about before I got here. I was running a little late. So there's no official university-wide policy as of yet. And he's predicting he'll be retired before there actually is one. So I don't know. We'll see. Things move real slow in academia. So, but I don't know. I know English profs are really upset about ChatGPT. Ooh, an AirPod. How can you tell who owns these if you just find one on a desk?
Throw away.
That's e-waste. It's e-waste. We can't just throw it away. It's probably someone over here who like sits up here, or maybe someone found it and brought it up here. Okay. I love technology and gadgets and cool things, but I lose everything. So I can't imagine that actually being useful.
Is that a chocolate rain ringtone?
It is. How do people do that with just like 2 bars? All right, I'll put it back on mute or vibrate mode here. Sorry, I don't know that number that called. I'm always worried like people call me and tell me that the stream died. I don't know, like I don't know what else you're going to do if you're remote. So I always have to preface that with this is an experiment. So good luck if it doesn't work. It's been really stable. Like it's a pretty phenomenal tool. So all right, excuse me. So we need to move on to new things, object-oriented programming in C#, right? Let me start a new project. Not the installer, not the installer. I was playing, someone was having trouble, their Visual Studio just doesn't work. And I was super sad because even uninstalling and reinstalling didn't make it work. And that's like literally the limit of my troubleshooting. Because it works for everyone else on every computer in our lab. So like, it doesn't work on your machine. I just get sad. I don't know what went wrong. All right, so we'll go build our project here. Should we do another Forms app? Do another Forms app. I think that's the right one. Excuse me. So this is week 4, more object-oriented. Good stuff. Great. It is a little slow. Okay. It's worth it, right? I think it's worth it. So in the form, we're not going to do anything yet. We'll come back to that in a minute. So we're going to take a look at some of these other interesting topics in object-oriented programming. So enums, I think this was a topic everyone was supposed to do in 200, where essentially it's like a specialty class that puts a name to a variable. That's all they are. So the cool stuff we get in enums, we didn't do this already, did we? All right, you got to stop me because I'm having a rough season. Winter's just been real rough, but I think we'll do all right. So in addition to putting a nice variable name to the meaning of something, enums in C# give us some other cool options here. So as we write out some enums here, let's go add another class here. So I'm going to go and add a new C# class here. Let's call this card. Our next project will be a card game because I'm entertained by games, and I feel like it's slightly more interesting to build something you can play. If you don't like games, I'm sorry. I'm sorry. That's all I got. Anyway, so card here. So in the card class, then right? We can go and make our enum for something. So say, hey, I want an enum, and we'll call this, how about face? Or let's do suit first, suit. And for suits, what is it? What's capital S? Probably capital S. There we go. We have heart, spade, diamond, club. Oh, I gotta put all those in quotes. Heart. Is it heart or hearts? I think it's hearts, right? Spades. That's true. Diamonds and clubs. No, why did it not like my? I don't like that. Hang on, I'm putting it in the wrong spot. Oh, no equal sign. Oh my goodness, friends. It we'll get it. We will get it one of these days, I promise. This is what you do. You write code till the red lines go away. Excuse me. I have an enum. I think we got to say it's public. That'll probably make this life a little easier here. Okay, and then we'll have a public enum for face. And we'll have, what do we have? We have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. All right, cool. Where's my format here? Format. Oh my goodness. Format icon. Control E D. There we go. That fixed it for me. Control E and D. So we've got a card class that has enums for face and suit. They're useful. And then the class itself, right? Public card. Our class for card first. Card. There we go. Put this in. Hey, look at that. Put it inside. So the class for card, then we need some values, right? To have a given card, right? It has a what do you do? Face or suit first? So face, suit. Right? So we should have some private attributes. Make this public here. We'll have a private face for face, private suit for suit, and my this face equals the face, and my this suit equals the suit. Look at that. I love when it suggests code for me and it works. So we can give a face value and a suit value. Fantastic. Okay. We can get that out. Excuse me. That's if you want to pick one here. What if we want a random one? Should we write another constructor that gives us random? That might be fun, right? Just pull a random card off the deck. Card. So if you don't tell me what the face and suit are, let's go pick one, right? So let's use random, right, to pick a random value out of our enum here. So let's get random equals a new random. That's what we're doing. Yeah, okay, so we can get next values out of random. This random class from the library. The default seed value, for our purposes, should be okay right now. We'll run into some trouble later if you do things really fast. The default value is your system clock time. I think down to like the nanosecond or something. We could go look it up, or probably millisecond actually. So if you generate two different instances of random at the same millisecond, they have the same seed value. And remember, most random number generators are pseudo-random. They're not actually random. They're because it's an algorithm. They can't really be random. It's really hard to do random stuff when the computer only does what you tell it to do. But to make it mostly random, it uses a starting value, something in the calculations, and that starting value is when they created the random instance. So most of the time, like if you run it now and you wait 5 seconds, you run it again, you'll get a different set of random numbers. So it feels very random. So if we're creating this instance of random and we're making 1,000 cards, like in a loop somewhere, there's a chance we're not going to get very random values. So we got to be careful about that. And we can take a look at that in a little bit and see if it happens for us or not. But excuse me. So we want to get a random value out of an enum here. And honestly, I'm going to go to ChatGPT because it's entertaining here. So how do I random an enum value in C#? Let's see if it can figure it out for us. Because otherwise I would just go Google it here. Look at that. Use enum get values method to get an array of all the values in the enumeration, then use random class to generate a random index within the bounds of the array. Here's an example of how to do this. How neat is that? It works. I'm happy with it. And I'm going to practice what I told you here, right? Because this is academia, it's going to have it here. So use ChatGPT here. That's all I need. Right? Is that easy enough? I'll just drop a comment in here. So we need to get the list here. So we're going to have an array of type suit. No, sorry, a suit array. Suits is my suit.get values, right? Was it get values? This is what I get. I didn't even copy paste it right. Let's see. Enum get values. Here we go. Enum get values. Enum get values from suit. Suit? No. Why does it want this type? Now it's not even copy pasting right. Suit is a type. Enum get values. Give it a type, an enum type, or give it type of enum. Okay, all right, so here we go. So let's try get values of suit. If this doesn't make a lot of sense, we haven't talked about generics yet. It works the same way as it does in C++, right? You use these cool diamond braces, diamond operators, and you put your type in here. You did that with types and template types. Everyone hates template types, right? But they're really cool. They're cool. So this doesn't give me red lines. Sure. We're okay here. So now I have the array of suits, I think. Now I should be able to get a random one. So I can say my suit equals suits index of, right? Random dot next suits length. Look at that. Suggested it for me. I love it. You got to stop me if I'm doing too much, or if I'm going too slow, yell at me too. I want it to be useful for you. Right, but we get our values. Cool. We'll do it again for faces. So faces of face, and then faces. I think we got enough of the copy pastes, right? Get them all, put them in a list, grab a random one. Get them all, grab them, put them in a random list, grab one. Should be okay. Does that make some sense? Let's see if we can do something with it. So now the next thing we're running into here, and I'm jumping around a little bit here, I'm sorry, to represent the card as a string. Later we can add images and do fun stuff with pictures, and that's much more interesting, but for now, just a string should be fast here. I can have get methods for my face and suit, right? We can have public suit, get suit sort of thing, turn suit, and public face, get face, turn face. Does it want uppercase? Okay, sure. Get face, get suit. Right, the green lines went away. I could do these and then translate them later, but it's nice if we have a way to represent ourselves as a string. It's a pretty common thing. Like if you just console write line, it's essentially turning stuff into strings. It's not going to look super pretty now. So in my form here, if I want a little button, let's add a button here for, we'll call this one, oh, I got to rename it first, oops. This will be get a card here. And how about get card button? Okay, there. Oh, it's still button one, but that's fine. We can rename that, right? Rename get card button click. Okay, I think that's probably fine. As long as you use the rename tool here, it should rename it in the design view and everywhere else we had it. If you just rename it here, you're going to be in for a bad time. That's how I think we got out of sync last time, right? When I tried to rename stuff and be cute. So that should be fine. So my form class then, right? We're going to have a card. We got a card. When we initialize, we should give values to all of our attributes. If you leave things as null, bad stuff could happen, right? And that sort of thing. So we can do that real quick. We'll put a label in and say, I don't know, card something. This is my card label. Give it a name. So when I get card, we're going to make card equal new card, and we'll take our card label, and we'll set the text property to card toString. Right? When you console write line, essentially everything is getting toStringed. It's one of the things console write line does for you, just kind of out of the box. So if we just see what we get here, we'll get that. Now we should be fine even if this is null, because we're not setting the text right away. Right? We're going to make sure it is not null here first. Might be okay. If you want to give it a random value first, might be better. You know, we got some options for what we want to do here, but let's give it a try. We'll get a card. Week 4 more object-oriented stuff.card. This is the name of the class. This is not a very useful toString operation. Similar to, I think you get it in C++. Like everything is an object, so you get objects toString. Did you override toString? I really can't think back to fall. It's rough. No? Okay. So what you're getting here with toString, you notice it's the real small text here, sorry, but this comes from object. So everything in C# inherits from this base class called object. So object is the base class. It has a couple methods. Now toString is not very interesting in object, but it's something here. At least we have some options here. So like card dot. So the get suit, get face, we wrote those, right? Equals came from object. Using this one is going to cause some trouble. We'll spend more time looking at this in a little while here. ToString comes from object. Get hash code comes from object. Equals comes from object. Get face is ours, right? Get suit. Oh, I'm sorry. Yeah, the get values gamer. Breathe. Thank you. I got to remember to watch chat here. Yeah, so get values. Where do we get that from? Is from the enum class itself. So it just has a way to get values out. Yep. So toString here is not very useful, but we can make it more useful here by adding our own toString method. Being a public string. Oh my goodness, was that uppercase or lowercase? Uppercase. toString. Now it's it's warning us here. This light bulb suggestion of what it suggests to do is either really good or really bad. So you got to be careful sometimes. So it's saying, hey, it's hiding the inherited member object toString. To make the current member override, add the override keyword. Otherwise, add the new keyword. The suggestions here are not what we want. Neither of the making it static doesn't fix our problem. We don't want that here. So the suggestion of adding override or new is what we really want. We haven't got there yet. We'll get to it when we talk more about inheritance, but new is not appropriate for this. We don't want to say it's a new feature here. We want to override. We want to do a different thing. Just like we did with C++, you can override, change the behavior of your parent class. So say public override string toString. And now it's saying not all code paths return a value. I mean, we got rid of some red. We still have more. Yeah, we haven't returned anything yet. So we want to return. And now this is where enums are more interesting. We'll come back here. You can get the string value of an enum here. Where's our? Wait a minute. I thought we had it right in here. I'm missing it. That's fine. I think we just say my base dot toString. I think that'll take care of it for us. We'll try it and see. So let's give it in a formatted string here. And we'll say, what is my face value? Like 2, 3, 4, whatever, right? Of, and then the suit. Oh yeah, and so toString, yeah, it's redundant inside of a interpolated string. So it's just telling me we don't actually need that. Right? We should just be able to get face and suit here and return that. So if I add the toString method to my class, right, when I use toString, I get this version of it. I think that makes sense. And we get a nice little indicator, hey, you're overriding your parent class here. This is nice. Visual Studio is a fantastic tool. Let's give it a shot. So now we get a card, 2 of clubs. Get a card, 8 of diamonds, 2 of spades, 10 of spades, king of clubs, on and on and on. Right? As many as we want here. That's kind of fun. What if we want more than one card? We do more than one card? Right? What if we wanted like a whole hand of cards or something? Maybe make a card array So lists are easier than arrays, right? Like using a vector was easier in C++ than using an array because they're not fixed in size. The term for that in C# is list. List uses generics, so we have to say list in this diamond operator of what? It's a list of what? So list of type card, cards here. Now, because list is an object, we have to create an instance of it, right? So our constructor's job is to make an instance of this object. So I can say cards equals a new list of type card. Now it exists in memory and I can interact with it. Until I've instantiated it here, I just have a variable, but it's null. Right? Just like any other variable, list works the same way. Until you create an instance of it to use that new keyword, you've got null. And when you try and use nulls, they break. And everyone's sad because nulls are awful. So now I don't want to make a new card here. I want to do some sort of loop. So for int, I don't know, card 0, card is less than, not cards count, card is less than, I don't know, 5 cards, card plus plus. Let's make a new card. Card equals new card. And then I can add it to my cards list. Cards.add card. Why is it unhappy here? Oh, I have, nope, the same variable name twice. You can't be an integer and a card. Go figure. So this is, how about card number? I don't know. Card number. Sure. I just hate I will try and go out of my way and spend ridiculous amounts of time not to use I, because I irritates me. Especially when you use I and have another loop and use J's inside of that, and you have I's and J's, and they look the same to me because I'm old and can't see very well, and I have to zoom things in. Like if I see I's and J's in a loop, I just cry. Anyway, all right, so we'll add it here. Now, we want to go and get all those cards out now and add to our text. So let's set the text to blank to start, and then we can say for, and with our for loops, you can do those enhanced for loops, right? So you can say for card in cards. These are those fun read-only enhanced for loops. I think you did these in C++, right? Maybe? You don't look sure? Okay. It's just a shorthand way of us getting out our loops here. Cards is not null here. No, in. I get confused by languages. I'm sorry. This is the for each loop. For each card in cards. This will look a little better here, like actual C# code that compiles. So it's going to go through the list here. So instead of saying for index is 0, index is less than cards.length, cards count, sure. Index plus plus. We could say, look at that. Cards at index is my card. Sure, why not? And then I can take my card label .text and I can append to it card. So same idea here. I just do this, and it saves me a little bit of time. So instead of having to get things out by index, it gives it to you with this enhanced for loop. The list is read-only. So when you have objects that have methods, you can call the methods on objects. The object is not read-only here, but what I can't do is change the value of card here and have it be changed inside of the list. Now this gets a little funky here, but I can't say card equals new card here and have it change. And it's even telling me, it's even failing here. You can't assign to card because it's an iteration variable. You can't change the value of it in here. You're essentially getting a copy out every time, which is kind of fun. So you can't go change it versus when you're looping through an array by index, you can go change the value at that index. So these enhanced for loops are really, read-only is not exactly the right term, because if card had a public function, that's not just a get. If it had a set, I could go and call these set methods. I can interact with the objects there. But the list itself is read-only at that point. You can't change where the list values point. It gets to be a little weird when you go through those. So but we should be able to get our text, set it to the card, and go from here. So we're going to make 5 cards, add them. They should double here. I'll go comment one of these out in a second. We'll make sure it works here and see if we can get some cards out. Oh, we didn't add any new lines. Oops, we should add some new lines. So card, let's do a formatted string here. Card and \n is probably fine. I think the more proper way here is environment.newline. This is better because Windows and Mac and Linux disagree on what character is a return newline character, because there are return characters and there are newline characters. There's \n's and \r's, and I can never remember who uses which, but they don't agree, and it has driven everyone crazy ever since. But it's probably too late to fix that, because I don't know, it's been years. So environment newline will pick whatever newline is based on the environment that you're using. Oh, it tells us \r \n for non-Unix, or just \n for Unix. Look at that. I love these little helper hint things. Tells us what it's doing. All right, and again, we got to fix that for this one as well. Let's give that a shot. See if we can get, now it'll look like 10 cards, right? But it should be 5 doubled. So 5, 3, 7, 9, 3, 5, 7, 5, 3, 7. Yeah, so we're getting different cards. Awesome. Worked out pretty well. So let me comment this one out for now. So as below, can modify list by index. That hopefully that makes some sense as we're doing these enhanced for loops. So these are a little easier to type, right? If we're just doing read-only stuff. Now we should be able to get some cards. 2, ace, 2, 3, 10, and like each time we do it, we should get different ones. Oh, why we didn't blank that out? Oh, we never cleared out the list of cards, so I was adding 5 cards every time, and that's why the label kept getting bigger and bigger. I was expecting it to be different 5 every time. So if you want to clear it, cards.clear, we'll clear out our list. Both loops gave the same output because it was the same actual list of cards. The cards was still the same 5 cards. We were just reading it by index or reading it with the enhanced for loop. It's the same cards. So yeah, Rinkaboo, you can change. Let me uncomment this here. There we go. So if I want, I can say, hey, cards at index is equal to a new card. Here, I can change what card, not that one, is being used in the list when you're going by index. So you can assign new values to a list by index this way. You don't have that option. You can't say card equals new card in the enhanced for loop. It just yells at us because it's not actually changing the value of card, because it's like pulled it out of the list here. So I'm not changing what's in the list. It'd be changing your copy here, and that's generally not what you want. So it keeps you from doing that. So this way I would get a bunch of different cards that are not in the list here because I'm not actually using the list anymore. Or, I'm sorry, I'm changing what's in the list. So the 5 cards we grabbed here are no longer those same 5 cards. We're assigning brand new cards here. So that's what you could do. So you can still modify values by index. That makes sense with this one? All right, so we can get some cards. We'll clear out our list so it's empty, put some more cards in it. If I had to use one programming language for the rest of my life, which one would I pick? Oh, I mean, that's a tricky one. That's a tricky one. I like Python a lot. I do really like C#. I think C# is more fun. But it just depends. Yeah, so all right, we can get some cards, we get some different things, and this seems to be working okay. All right, so that was our card class, using enums to put nice names to things, and then the enum itself just spits out as a string really nicely as well. Right? It takes the value of it right here as a string, which is cool. So behind the scenes, when I hover over this, it says, hey, ace is 0, 2 is 1, 3 is 2, 4 is 3, which is a little weird, but that's okay. Enums get assigned numeric values. Because remember, computers are really good at comparing integers, and integers store relatively well. I mean, if you're going to have more than 2 billion values in an enum, you've done something wrong. Right? We're just not going to run out of room because an integer can hold like 2 billion numbers, right? Because ints have enough room for that in the 4 bytes it gets. Versus if we were to store things as strings, each character is generally 2 bytes, right, with our Unicode system. So you have 2 bytes of information for every character of your string. So storing things as integers is much more efficient in our classes and in our code and in terms of our memory use. And then comparing those things is better as well. So if I want to compare the string ace to the string ace, that takes a whole lot more computational power than saying just 0 equals 0. Because what face.ace actually is stored as is the number 0. So C# could say to 0 equals 0 really quick, right? Where it's really fast with those sorts of things. So it gives us some better performance as well for using enums. It's not just because it puts a nice name to things, which I'm all about. I think that's fantastic here. And then again, the benefit of doing it this way, rather than class having like, here's a static int ace equals 0, like we could do it this way and give all these values as static values, but then we can't use these sorts of things as strings right away. We can't do these cool enumerations over our, get all the values out to get random values here. So there's a couple extra things we get because enums are fun like that. They both can get the job done. If you want to list them all out as static attributes, that could work. You're just doing a lot more work than you need to at that point. So if you've figured anything out by now, we want to do the least amount of work to get the job done. I think that's on my splash screen. I like to say good programmers are lazy, right? But lazy in that we want to be efficient. We're efficiently lazy people. So like doing a bunch of busy work is really obnoxious to most developers, and we don't like that sort of thing. And we look for ways we can make things better. So it's 7 o'clock now. You folks look bored. Should we take a break? I'm bored. We can take a break. Get up and stretch. All right, awesome. We put some music on here, and we'll come back to you in a little bit. A random function that excludes 0. So you just need to. So Fluffy, you just need to add to your value. So random next, right, will get you 0 and up to, but not including that number. So if you go random next 6, you'll get 0, 1, 2, 3, 4, 5. If you just add 1 to it, now you have 1, 2, 3, 4, 5, 6. Does that make sense? Yeah, Gamer, what's up? Guess I'll wait to put on the music a second. So I think next you can even give it next a range, right? Random next. I think you can give it. It's got overloads. That's the max value. Where'd the next one go? Oh yeah, you can even give it a min value. So you can say 1, 6. But the upper bound is excluded, so it'd be 1, 7. Yeah. So I think 1, 7 is probably would also work as well, right? Or random next 6 plus 1, right? I think that's probably pretty similar as well. Yeah. So if you only have 7, you're going to get 0 to 6. You don't want 0 to 6. You want 0 to 5 plus 1, or you want 1 to not including 7, which is 1 to 6. Random. And then number 1, 2, 6. Also random number 1 to 6. Is that fine? I like funny variable names. They entertain me. All right. I think if we're good there, then I'm going to put this back on. So you can't do the plus inside the parentheses, do order operation. So do in the parentheses and then. What did I do? You folks are kind of up with me. All right. We got 7:16 on the clock. Hopefully you got a chance to get up and stretch. Forgot to go do that, but that's okay. We had fun. I'm talking about viral YouTube videos and reliving my childhood. So, all right, a couple other things to get to this week. We did enums, one chapter. That's all right, we're getting there. Tuples are really cool. They're just essentially shorthand for having to make a class, because sometimes it's a lot of work to type stuff. It's not all that much work, but if we're just using, like, want to pass around a couple values occasionally here, tuples are really nice. So now suit might not be the best example of this here, but we're going to make it work, and it's going to be awful, and it's okay, because they have better examples you can look at elsewhere. But if I wanted to, say, return the numeric values for face and suit, just because, and return two different numbers here. Say I want to give you an int and an int from get, I don't know, numeric values. You can't do that, right? It's not letting us do this. Like, I don't know what you're talking about. You can't return multiple things, right? Methods can return a single value, right? The trick to doing that is technically, like a list or an array or some sort of collection or an object, another class, is a single thing. It just holds a bunch of other stuff. So the slow way to go about this here is we could have another class if we wanted. And I don't recommend this. This is the reason why we have tuples instead. So we have two numerics. Public class, two numerics. And then we are going to have two values. So we'll have a public int value 1, public int value 2. And then we'll write a little constructor here for fun that will take a value 1, an int for value 1, and an int for value 2, and assign, oh, look at that, we can even use, value 1, value 2 equals value 2. There we go. Okay, and they're public properties, so we get the get and set methods out of the box for these. Okay, this works out pretty nice here. So instead of returning an int, I can return two numerics, right? And then I can return new two numerics. Now I want to give it my face dot get value. Where is it? Face dot value. Oh man, what is it? There's a get type. No. Code, type code. There's a to get the value out. Maybe I can just give it face. Suit. No, we can cast it as an int. That's what we can do. So we can tell C#, hey, pretend it like it's an int, because it really stores an int value behind the scenes. I thought there was a shortcut to do that. Let's go ask the chatbot. I'm really entertained by this thing, if you can't tell. You get the numeric value of an enum in C#. Oh, error.
I think you could refresh the page and then.
Man, come on. You get the numeric value of enum in C#. Let's go.
Yeah, there you go.
Thinking. All right, Googling would have been faster at this point. Oh, casting with the int operator. Look at that. We did that. I'm not going to cite my source because I did it before the bot. All right, that's fine. We'll let that have some fun. Cool. So the integer of the face, integer of the suit. Again, this is a lot of work just to go and get these out here, right, to pass these around. So the easier way of doing this is using a tuple. So I'm going to say, hey, I'm just going to make another method here just so we can compare them side by side here. When I make my method, I want, where is it here? I think I just got to put them in parentheses, right? Where's my, there we go. Get score, yep. I think that's just it. There's a lot of cool stuff here. They're fun. I think I can just say int as a tuple here. other get numeric values. And by virtue of putting them in parentheses, C# says, oh, you want a tuple or tuple. Some people say tuple, and I make fun of them. I've always said tuple, but some people make fun of me too. So whatever, however you like to say it, tuple or tuple. I don't know if there's actually a right way. Now I'm curious. Pronounce tuple as tuple or tuple? Tuple, not tuple.
I was thinking like when you're talking about
Oh, ouch. I lost. Tuplets, tuple. Tuple just sounds funny. I'm going to keep saying tuple, and you can make fun of me, because that's okay. All right, so we're going to return, and then we just throw these things in parentheses here. So what's happening behind the scenes is it's sort of anonymously generating a class here that looks like it will hold these values. So it does this thing known as packing and unpacking. So it will pack the values into a tuple for you here, just by giving them values, and then it can unpack them. Now, to use this, it's a little bit funny here. So let's go back to our form. Let me go add another label here just for fun. So let's take a label, and this will be the numeric value label. Sure. And when we get a card, let's take the numeric value label, and we'll set the text to, we'll do a little formatted string. Now, I need to go and get the value out. So when you have cards in a list, you can do cards and index values. Indexing is fine. You can also say cards dot get. No, that was at element at. You can get the card at if you like different syntax. So like in C++, we use vectors. You can use the array indexing, or you could use the at method. The array indexing didn't give you the bounds checking though, so at was better, right? Everyone used at all the time? Better for you? No? Okay. But let's just go get the first card out here, and then we'll call get numeric values here. So this is going to return the two numeric values method. So then I have to get the value 1 out. This is kind of ugly here, but it can work, right? And then get value 2 out. So get the first card, get the numeric values method, get value 1. That's returned from that. Right. If you don't want to have to call this twice, right, we could have an instance of these get numeric values. We got options here, but this is getting it via the class. If we want to unpack these things using the tuple or tuple here, it's a little different. So we'll take our numeric value text and let's add to it here, because this is what we're going to do. We'll take cards at index 0 again, and this is the other get numeric values method. Now this one is going to return two things for me. Right? It's returning an int and an int. So if I want to get the first one, nope, not 0, dot item 1. So it names them for us. So item 1 is the first thing in the tuple. Item 2 is the second thing in the tuple. And you can jam these tuples full. I think there's a limit. It's more than 16, I want to say. Sharp max size of tuple items, something like that. Oh, 8, okay. Up to 8 elements here. If you've got more than 8, I don't know what you're doing. Something crazy is happening here. So probably use a real class. It's like item 1, item 2, item 3, item 4. It's going to be really hard to remember which one is which. But for two things, you're like, okay, here's the first thing, here's the second thing, and you're probably okay. So there's 1, and then we'll do it again for item 2. Item 2. So we should get out the same values here, right? Whether or not. So this value 1, value 2 is specifically because we put it in the class here for value 1 and value 2 as properties. When you use a tuple, you just get item 1, item 2, item 3, item 4, item 5, whatever, up to item 8 here automatically. Because behind the scenes, it's this syntactical sugar, right? It's actually using a generic type, and it matches and says, hey, this is the right generic type. So I don't know if you saw, like, you get this cool like T thing here. Like item 1 says gets the value of current T1, T2. So if you think back to your template types, there's actually a template type of tuple of size 1. There's or size 2, I don't think size 1 makes sense. A template type tuple of size 2, a template type tuple of size 3, a template type tuple of size 4, a template type tuple of size 5 that is in the C# library. And when it sees one of these things, it says, oh, okay, sure, I'll use that type for you. That's the template type you want. They're just giving us some of that behind the scenes, which is awesome. So the language is full of shortcuts. I love it. So the tuple can return up to 8 fluffy. I'm sorry, I'm going to try and pay more attention to chat. Yeah, 4-0, 4-0 repeated, right? Because we're doing the exact same thing twice. So this first card, right? 7 of clubs. So 6 is the numeric representation of 7 because we had ace first, but ace was 0. So all of our numbers were kind of off by 1, and then clubs was the last suit. So I think this makes sense here. So I think that works out okay. So writing your own class for storing 2 values here and having them be public properties, not hard, right? But if I can just use a tuple instead, why would I go do this? It's not like I'm going to be using this 2 numerics thing all over the place. Now, if you're going to use it a lot, it probably makes sense to have a class for it. But like if you just want to pass a couple values one time for one thing, the tuple's really fast and easy. There's this idea when we go and design code solutions, when we're thinking about how do I want to solve problems. Maybe you're not like me, but it's really interesting when you start designing solutions to think, well, this would be cool if we did it this way, and I could add this in so that later on I could go and change it, and maybe somewhere down the road that if I have a class for it, this sort of stuff, and you end up doing a lot more work than you need to, because all you needed to do was return 2 values. And you're like, oh, well, maybe later I'll go and do this. So this is over designing essentially at this point. I didn't need to have a class just to return 2 values, right? I can do it the short way. And then later on in my code, if I'm like, hey, I'm always returning those same 2 values, I'm doing it in 5 different places here. Now in your head, you're like, okay, it's probably worthwhile to build out a class here and make this a quote first class item in my solution. Now I have a real class here that represents this. I can put nice names to things, and I don't need value 1 and value 2 because I can actually say this is what it really means here, right? Here's the face numeric value, or here's the suit numeric value, and put some names to what's happening. Because, when we just look at it, you're like, hey, what is item 1? What is item 2? I mean, the method name says other get numeric values. Like that's not even all that super helpful for what's happening here. So, if you name your method right, maybe you can indicate what's happening here. But if you're doing it a lot, then we want to go to the class route. But tuples are just a nice little shortcut for us to say, hey, let's go in and set some values. Now, you can abuse tuples, and I don't recommend it. You can have someone pass you a tuple of something. This gets really awkward, right? When you start asking for tuples to be passed to methods as arguments, you're like, sure, we can, yeah, okay. You can name your variables that come back from things too, which is fun. So, right, tuples, item 1, item 2, so on and so on. We can give them names instead if you want. So as long as we're not using var, we can assign names here. So I can say, hey, when I get this back, I want to call it something on the receiving side of the tuple, which is fun. Excuse me. Or you just keep your item n value here. You don't have to name all of them. Mixing and matching like this is really awkward, but people do all sorts of weird stuff in code because we can. So if you see it, hey, it's okay. Like I'm going to give it a name for my variable, and then I just say it's an int and an int. Sure, we can do stuff like that. So you can. It just gets a little weird here. Our dynamic properties, like when we said, hey, we can the get area is computed sort of thing. You can also do tuples with that sort of stuff if you want. So you could have it like, hey, here's all sorts of shaped properties and give back multiple things. But I mean, probably easier just to do one method at a time. Sorry, my sugar's a little high. See if I can. All right. So they're fun. Just some shortcuts though, right, of how we want to go about doing these sort of things. So doing an array of tuples, just because you can do something doesn't mean you should, right? I think someone has a good quote. Was it with great power comes great responsibility, right? Anytime we're doing stuff in code, it needs to be readable. And you can probably figure out what this means here, but it's going to hurt your head a little bit the more you look at it. So if we can take a minute to make our code look better, it's probably worth it here. So there's just a shortcut. Use them here and there, and you should be okay. So you can, let's setting our score. You can discard items that you don't want here. So this is pretty common. You'll see this in a lot of code. If you're returning a tuple and you just don't care about some of those values, our underscore character is saying, I intentionally don't want this. I don't care what it is here. I just want to get rid of it. So we can say, if I don't care what that second item is here, I can have int and an underscore numerics equals cards of 0 other get numeric values. Why is it not throwing it away? I broke it. That's my tuple one, right? Didn't do it. Me? Why didn't it do it for me? All right, it's not cooperating. We should be able to get rid of it here, maybe because it's coming back from the method. It's just a visual cue that we don't care what this value is. Tuples for quality, sure. Okay. Now we got through one chapter. No, tuples was the second chapter. We got 2 chapters down, right? Okay, feeling good. Feeling good. Yeah. For making them or for? So we just throw stuff in parentheses to make things a tuple. So this one's failing here, but numbers. So in my card class, when I go to return something, I just throw it in a set of parentheses. So it is in parentheses, value, comma, value, comma, value, comma, value here. And the return type is just in parentheses, the type, comma, type, because we don't put names in here. Those were the items that were returning or what? So what I'm going to return is a tuple of the first value will be an integer, the second value will be an integer.
Is that why you return multiple values?
Yeah, because technically this method is only returning one thing. It's returning a tuple. The tuple just happens to have 2 values. So the rule that methods can return one thing is being followed. Because a tuple is one thing, it just is a container for multiple things. Just like if we were to return a list or an array.
Where does that method get used? So I can see like what.
So,
how did you declare a tuple like as a variable?
So we did it in the label here, or we can say, hey, I want to save that result here. I'm going to call it numbers. It's a tuple of int. It's going to be the result of this function.
Do you have tuples like an integer and a double?
Yeah, we can have any types we want. Yep.
And if we want to make a third item, we just comma and that.
Yeah, so we could have public int string double garbage turn 0 quote 0.0 lowercase s string, right? It likes lowercase. So you can make tuples out of anything you want. You can mix and match the types. So it is a little more flexible than a list, right? Where a list would be all of the same type. So this is, we compare these to, like, it's an anonymous class essentially. You can build your own class and have properties for different things. Same idea here. It's just giving us a little shortcut for it. Now I have different types. Yeah. Where we're using it here. Yeah. So we're just kind of chaining these things together here. So the list of cards, index 0 is a single card. The card class has a method, get numeric values. Get numeric values is the class we wrote that has properties for value 1, value 2. So that's using the class version. This is using the tuple version. Our other get numeric values returns a tuple of int. And then to get those out, it is item 1, item 2, item 3, item n. Right, as many items as we have using the tuple style, rather than having a full class that's written and defined. Yeah. No, so you don't name things on the sending side. you can name them on the receiving side here, but we don't put names, like, just like I don't give it a name for what 2 numerics is. It's a type here for what we're returning. So we would name them, like on this side, I could say, hey, this is face int, I don't know, and suit int or something. Right? I could name them on this side if I wanted here. And now I'll have numbers.faceInt and numbers.suit, and like, so again, if you're spending a lot of time naming things because you don't know what it means without a name, you might just want to go the class route, right? And have, I mean, value1 is a terrible name here. I'm feeling bad about this. We should change it here. So let's rename this here to, this is my face value. Here's my suit value. Not suit face. Oh my goodness, suit value. There we go. Sure. So now, like, I have nice names with the class version here rather than item 1, item 2. But we could go and name them when we call them here. You know, so it's all about how much work you want to put into it and what we're trying to get accomplished with it. So, you know, we're doing one thing one off, right? Use the tuple. If you're doing it 5 times and they have nice meanings for what these are, go use the class. Go write a class. Like, it's not hard to write the class, but you know, for one thing, we don't always have to. It's just a shortcut. All right, classes we talked about, right? We did classes, we did information hiding, we did properties. Static is fun. So this is actually works the exact same way that static works in C++, which is nice. So static means it belongs to the class level, not every instance. So instance attributes are what we will typically talk about with classes, because that's when we think of desk, right? You can think of n number of desks, each with their own set of properties. Not all desks have the same set, where the static properties are defined at the class level and shared among all of them. So when we have attributes or we have properties or we want to count something that is shared among all instances of that class, we can make things static. Or things like math. You don't need an instance of an integer to do stuff in math, right? The math library is all static functions, static methods. You just give it values and it gives you something back. You don't need an instance there where you have a bunch of attributes already in memory. So depending on how we write our code, we can do things statically, we can do things with instances. You can do a lot of weird stuff with static. Depending on what we're trying to do, it's good or bad. I would recommend, in our card class here, I mentioned if we're not careful here, using random like this is going to cause us some trouble. Because then every time I make a new card, it makes its own new instance of random, and maybe we just do it too fast and bad stuff happens. So it might be better then, instead of having random be in the constructor of an instance, where every instance needs to go and tell C#, hey, make a new random, which is not free, right? It takes a little bit of time and processing power to make an instance of the random class so I can get random numbers. That could be a static attribute of the class. I could have a static random here. So that way, when the class is loaded for use, this instance of random gets generated as well. And then random can just be used inside the class. So when I create 50 cards, I don't have 50 instances of random being created and thrown out, created and thrown out, created and thrown out, because it would get garbage collected. It's not gonna waste all that memory, all that time, all that processing power. It just creates it once here and is used among all of them. So the slight downside is that random will exist in memory pretty much anytime card is around. So it doesn't take up a lot of space, so it doesn't really matter here, but it's going to keep random in memory after I'm done using it, because I'm going to make my card to be done. I don't need it to stay around anymore, but it's still there because it's loaded at the class level. So ever so slight downside here. That's a bit more of the sciencey, like what is a good trade-off for this, making it static or making it not static. And for our purposes, we don't really care too much. So it's probably better here, right? Yeah.
If you discard all your cards though, like if there's no instances of cards, will random disappear then? Or
so because the program has used card, it's still going to keep that definition in memory. So like when it uses the class, it's actually loading the class definition somewhere. And that's where all the static stuff lives. So just because we don't have instances of card, we still have used card, and I don't understand the garbage collector completely, but it's likely going to keep that around just in case you need to do card again, because it doesn't want to have to go through and read the class into memory again.
Probably as long as the program is running.
Yeah.
Maybe.
Yeah, and for everything we're going to do, yeah, it was going to keep it. I imagine at some point you could make it do smart things and unload classes, but that's a lot of work to force it to unload things. Yeah, that's a good question though. That's those like fine level detail things. I don't know. Go take the compiler class and learn how those work, because we need smart people to work on compilers. Because I don't want to. So it's not interesting to me. All right, so static. Right, they belong at the class level. Give it the static attribute. Properties, methods. You can have static constructors because the constructor's job is to give values to attributes. You can give static attributes values in your constructor. And the idea here, if we want our properties like to be set as read-only, read-only is a nice shortcut so that once it's set, it can't be changed. So we can add in here, hey, my face and suit here, we can say it's read-only. Read-only, face and suit. What that means is now I can't go change it, even inside the class. So if an attribute is read-only, it can only be set once. And generally that's in your constructor. So now I can't add a method like set suit, given a suit. I can't say this suit equals suit. It's going to yell void. It's going to yell at me. Should. There it goes. All right, once everything else was happy. It says, hey, suit is read-only. You can't go assign to it except in a constructor. So if I don't want that to happen, I can put additional constraints around my values here, which is nice. So some classes we don't want things to change. We want them to be immutable or non-changeable. Don't change those properties. So sure, once you have a card, it is always that card. Great, that's your business rule, go for it. If you want someone to be able to change the card, let them change the card, right? We don't have to make these things read-only. It's just an option here. So it depends on what problem we're trying to solve and how we want that to work. Right, so if we imagine like our Yahtzee dice as a class, we had 5 dice in a class, and you can like set the dice to roll or not roll or that sort of thing. You don't want them to be read-only because you want to be able to roll the dice and change their values, right? So read-only doesn't make sense for that because they should be changeable. I should be able to change the value of my dice when I roll them, that sort of thing. So just gives you some options. Let's make like face read-only, because then we can have a set suit, and why not? I don't know. Well, we can be a magician. Be like, look, it's a 2 of clubs, and now it's a 2 of hearts. And everyone says, ooh. I like watching magic videos. I don't know. It's entertaining. All right, so static stuff. Yep, awesome. Full references. Hey, thanks so much for donating your Prime sub to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. Appreciate you dropping by. So nulls crash our programs, right? Null references are real bad. We don't like when things are null. So anything that is not a primitive type is possibly null. So like the primitive types like ints and doubles and floats, those are primitives, right? The other stuff, classes, are reference types. They will reference something in memory. We're not storing that value directly where that address is, that sort of thing. So it can be null. We want to be a little careful here that if it is null, we don't crash. So we get some cool sort of like safety features around nulls. So let me go and make another class here for fun. Add a new class. We'll call this a hand. The public class hand. Now, hand, then we're going to have some properties for cards. So we'll have a public card, card 1, public card, card 2, public card, card 3, public card, card 4, public card. Oh, I want capital letters here, sorry. Right. It's warning me here. Now these are just warnings, right? It should still compile here. That non-nullable field, card 5, must contain a non-null value when exiting constructor. Consider declaring the field as nullable. This little declare as nullable adds a question mark. And these are fun. So the question mark is my way of telling the compiler that it's okay if this thing is null. I'm going to deal with it if it's null. If I don't have it, it's going to warn me and give me all sorts of clues like, hey, you might have done a bad thing here. But if I'm okay with this thing being null, like if we're playing a slow poker game where you draw one card at a time because you can make up any way you want to play cards, that's fine. Sure, maybe I only start with one card in my hand, and then maybe I get a second card, and then maybe I get a third card, and I'm not always going to have a bunch of cards. Now, again, you might just think you'd use a list, and that would make a lot of sense, but that doesn't help for our illustration of this example. So a list would probably be better, yes. But if we're just working on it here, so public hand, right? We don't have anything right now at all. So maybe card 1 equals a new card. So we'll get one card when we start a hand here, and then we'll say card 2 is null, and card 3 is null, and card 4 is null, and card 5 is null. Maybe this is what we want. Again, just for sake of argument here, we're going to pretend this is a crazy poker game. Yeah.
So you can make instances
yeah, so instead it would be better to say, hey, list of type cards, this sort of thing. Like, actually, public is probably bad here. That would be private. This would be better here. No, so lists are like vectors. You can just keep adding to them or subtracting from them or clearing them out. They're dynamic. You would like loop through the list of cards, just like we did like with our form here, right? We have a list of type cards. You just loop through, and as many cards as I have, I do something with. So yeah, so we got options. So this is better way with the illustration. Is that fair to say? So I'm going to assign these things null here and give them specific values. So then if I wanted here a public override toString here, don't want that. If you want to say, hey, how do I want to represent my hand as a string? Right. Well, let's do that. So I'm going to say, here's my string per hand. I'm going to start as quote, right? And then we'll keep adding to it. So I can say, hey, if card 1 does not equal null, hand plus equals card 1 toString. Look at that. This is fun, right? And we can go through. We can check each of our cards as we go. Card 3, card 4. Card 5. Oops, I should change these ones too. But this is a little tedious, right? It wants to change it to card 3 for me. Look how cool this is. Oh, not card 3. Oh man, I lost the pattern. All right, it's failable. This is why you can't trust the machine, right? Just like the ChatGPT tool. What is it? Trust but verify. I think someone else said that. I'm full of ridiculous quotes. Right? And eventually we can return the hand. Okay, this is real tedious though to have to check each one of these, and the list would be better, yes, that sort of thing. But what we get to do, if these things are declared as nullable types, that it's okay to be null, we get some shortcuts here. So the idea is what we can do is I can say, is it null or not? Okay, so as I'm using it here, I don't need this. I can get my score. Where did it go here? Checking, here we go. Checking if it's null or not in my operation. It gets really funny. So what I want to add in here then, excuse me, instead of going about this way, I want to take I'll say a string other hand equals something else. So let's start it here, and then I can take other hand, and I want to add to it if card 1 is not null, toString. If it is null, we don't get the toString. Card 2, card 3, card 4, and card 5. And let's return other hand. We can return them both. Let's return a tuple of strings because that's ridiculous. We'll return string. Return hand and other hand to compare them here and see what we get. And we didn't add any spaces here. This is probably going to be a little ugly. We probably wanted some spaces in here or some new lines, but we'll come back to that later. It's okay if it's ugly. Yeah.
So that override, the override word completely replace the definition.
Yeah, so we've overridden our, oh shoot, because we're not overriding it anymore because I changed it. So this is no longer an override. We'll just call it get strings. Okay. Yeah, so it wasn't overriding anymore once I put the tuple in because I wanted it to use a tuple. All right, so we'll return both versions of hand. So if it is not null, it will continue on and to run this. If it is null, it stops and we get null. So this is a shortcut way of saying, hey, if it's not null, do something. Right? Just more syntactical sugar if we're declaring these types as nullable types here. If it's not a nullable type, we can't use our shortcut. So let's see if we can't make our card here. Oh, we need a hand, right? So let's make a new hand. Let's add another label then, right? So let's add a label. I'm just going to throw these all over the place because, again, I'm bad at this sort of thing. That's okay. This is our hand label, sure. And then we'll go make a hand label. So hand equals a new hand. And my hand label dot text is going to equal hand dot get strings. And we want item 1 or item 2. Maybe we'll take item 1 and then we'll add item 2 as well. Hand label. Oh, okay. Let's do it all in one. Let's do it as a formatted string. So item 1, a new line, environment new line, and then item 2. This is getting long. That's okay. Get this item 2. Let's see if we can't get both strings out. So we'll just set the text of the label to the first version, right? That item 1 string, which was checking if not null, if not null, if not null, if not null, adding. Let's see what we get. Shadow of Hearts. We get the same version. This is good. This is what we want here, right? So what we're getting is this shorthand way of dealing with if something's null is just null. If it's not null, then please continue on. So what you're going to see is you get this whole chain of nonsense, and it looks really ugly. But what's nice here is that, hey, I'm going to give you a nullable string. You might get back null. You might get back a string. Be ready for it. And then, at compile time and when we're building and writing here, you were indicating that null is an option to whoever's calling this method. You always could return null, but it's really bad form to give someone null when they're not expecting it, because it will probably crash. Right? If you say your function method returns a string and you give me back null, I'm going to be real sad because I thought it was going to give me a string. But if you say, hey, you give me a nullable string, then I know I have to go check and see if it's null or not. So it adds some extra bounds checking for when we're writing our code and using code or using other people's code for what we need to be looking at. So then you can put together this crazy list of, if this is not null, do this. If that's not null, do this. If that's not null, do this. So is there a score manager? Is that null or not? If there is one, then get the scores. If you get something back from get scores, so the score manager has some scores to give me, go get the first one. If that first one exists and is not null, so maybe there was a scores, but it was empty, there was no 0 index because we had no scores added. If that's not null, go get the name. Right? So we get this whole chain here of, and writing this in a bunch of if not null, if not null, if not null, if not null is going to be ugly, right? We're going to have to say, hey, if score manager is not null, get scores equals something. If the get scores, whatever we called get scores, is not null, then check this, get the first item. If the first item we got out is not null, get this one out. So we can see it saves you a lot of time here of having to do that null checking. And that's sort of it. And hopefully you got into the habit of checking for nulls in 200, because we started getting into using objects and all sorts of interesting data structure stuff, and who knows what we're going to get where, right? So maybe things giving me back null and we can run into trouble. So you can check really nicely here versus this version. Hey, if it is null, return null. Get the scores. If that's null, return null, right? So 6, 7 lines here versus 1 line. Now, until you've read this a lot, this looks like garbage, and I apologize. All sorts of interesting shortcuts look really weird at first. So it takes a little bit of getting used to. But so maybe this makes more sense to read at first. But developers love doing this question mark stuff because it's a little shorter, a little easier for us to write. And generally well accepted that we do this sort of thing now because it's a feature of the C# language we're going to take advantage of. Yeah, Fluffy, I could have done the \ns instead of these new lines. Where did I do all those new lines? Yeah, this environment new line. This is just more preferred to \n because technically it's supposed to be \r and \n for non-Unix platforms. \n's work, but it's a whole thing. So this is just better. I don't know. Someone smarter than me told me it's better, and I've just done it ever since. So nullable types, checking for nulls. The other thing you can do is you can null coalesce here. It says, hey, if it's null, give me something else here. So similar to how we could say, hey, let's check. So if it's not null, add it here. So maybe we might say then else hand plus equals no card 5 or something like that. So just in this one example, we're just going to throw in there's no card 5 because why not here? So what we're going to add here then is if it's a string, let's do something here, or I can go give it a default. So if it is null, this is what I want you to show instead. So again, just a little shorthand. Oops. There we go. I was in the wrong spot here. No card 5. So if card 5 question mark, if it is null, give me the null coalescence, give me the default. If it's not null, keep going and do this thing instead. So just like the ternary operator, like we can say an if-else expression kind of in one line. Here you can assign a value if this is true, take this value with a question mark, colon, this value. Same idea here. We just, if this is true, get this, otherwise get this. But specifically around nulls here. So now we should get no card 5 in both of them. So, 2 lines or like 2 question marks and some other code versus an else. Maybe it's prettier. I don't know. This sort of shortcuts I appreciate, even if they're confusing for a little while. Once you do it enough, like the question marks don't look funny anymore, but they will look funny for a little while. So having card 1 question mark means if it is null, is not. So card 1 question mark says card 1's nullable. I might get null. If I don't get null, please do this thing with it. Right. So that's what this question mark nullable check is doing for me. Now, if you don't want things to be null, don't mark them as nullable, and you're probably okay. I mean, you still can screw up, and if we don't assign values in the constructor, bad stuff will happen. And again, but there's other ways we could work around it here. Like this idea of having a list of cards is probably better, but let's just run with the example for now. Holy crap! It's 8 o'clock already. Do you want to take one more break now, or a couple more minutes, or I think we can get to inheritance and polymorphism and interface. Oh, geez. We might not get to interfaces tonight. At least let's at least finish up with inheritance and polymorphism tonight after we get back from break, okay? That sound good? We'll take 10, go stretch. I'm actually going to get up and stretch this time. We'll go from there. All right, awesome. Leave 10. Alrighty, I gotta put on repeat is what I need here. There we go. Repeat all. That'll work next time. All right, so a couple more things. I don't want to run super late tonight, so we might not get all the way through inheritance and polymorphism. So I think this is pretty good because next week we're going to go over Yahtzee, and then we'll finish out this chapter or this section, and then we'll talk about the next project. So next week will be relatively full. I don't want to leave too much there, but should go well enough, I think. If we can get through inheritance, we'll be okay. Polymorphism is not a new term, right? Everyone did this in 200? Okay, good. Sometimes the coverage varies wildly, and that always confuses me because like they give us a list of things we're supposed to talk about. I don't know. I talk more about certain things than other people for sure, so I guess that makes a little bit of sense. So, but inheritance, your base class and your derived class, your parent class and your superclass, your subclass, or no, subclass and superclass, your parent class and child class, go for it. We use base as the keyword in C#. So base class and the class that derives from the base class is great. I always like superclass and subclass. That's what I liked. And then Java, you use the super keyword, and that's what I started with years and years and years ago. So you'll probably catch me saying superclass and subclass, but means the same thing, right? It's just different words for the same thing. So works the same way. We say, hey, I want to inherit from another class. You create the is-a relationship. You is-a of your parent class, of your base class. Terrible English, I'm sorry. But like all squares are rectangles. A square class could inherit from rectangle. It is a rectangle. It has all the properties of rectangle. And then what makes it special? The reason why we use inheritance is to add new functionality to classes, to extend the class without changing the original. So depending on what we've done with our code and what kind of code we have or what we're working on, the project we're working on, maybe there's a class that's being used a lot of places because it's a very useful class, does a lot of cool things, but I need to add functionality to it. I have two choices. I can change the original class and then make sure I didn't break anything everywhere else that is being used. That sounds a little scary, right? Because if it's being used everywhere and I went and changed it, I don't want to break other stuff. It is an option, right? It is doable, and sometimes that's the right thing to do. The other thing we can do is we can inherit. We can say, okay, I want to do everything that class does and then make it special in a new version and then just use that new thing where you need the new thing, new functionality. You're not changing any of the old stuff. You're leaving it as is, but we're going to not reinvent the wheel. I don't even need to copy paste. I just say I am a one of these classes. And by the way, here's what's special about me. Here's what's new about me. So the rectangle, square, polygon sort of example is really boring and dull, but it works pretty well. Other fun inheritance examples, they're not too bad here. So let's add a new class, I guess. Let's add a class for, how about mammal? Is that 2 M's? Mammal? Really bad at spelling, I'm sorry, but that's okay. So we have a class for mammal. So what do mammals have in common? Right. So if we think about classifications, right, the kingdom, phylum, class, order, family, genus, species from biology, that should not be in my head, but it's in there for some reason. I don't know why.
Multi-celled organisms?
They're all multi-celled organisms for mammals, yeah. I think that comes from a little higher up in our hierarchy, right? Okay, so fur color then, like if we all have fur, what would an attribute of a mammal be then? Like fur color? Is that
sure?
Okay. String fur color. Sure. Oh, I missed all these gets and sets. I was doing a bad job of that earlier with properties. That's okay. Public string gender. Okay, we can add gender for mammals. Gets and sets. How about weight, maybe? And then I always like pointing this out because it drives me nuts. When you use something that's measured in a specific unit, please include the unit in the name, right? So weight in kilograms rather than weight, and people just have to guess what sort of unit you're using. Yeah, definitely name, like string name, I like that. So is this the like common name or like species name, or is this the like my name is Eric name? Okay, so just name. Okay, yeah, cool. Yeah, that's that. Definitely. So I could name off all of my cats. Look at that, it was suggesting description. That's cool. Do we want to add a string for species? All right, then that's probably enough for our example here, right? Species, get and set. Sure. Oh, age, yeah. Public int for age, get and set. And then again, I'm doing the same thing here. So age what? How are we measuring age? How about in years, right? So get and set, semicolon, there we go. Yeah, date of birth might be better to calculate rather than age, but this is, either way is okay. Dates and time are a nightmare in any programming language, and I hate them. There are types for date and time sort of things. There's also types for just date. There's also types for just time, because date and time in my time zone is different than the date and time in a different time zone. And if I say my date of birth is April 22nd, 1987, and I am using a date time object, and I say, okay, it must be midnight for default, and then I go move to a different time zone and look at what Eric's date of birth is, I was not born on the 21st. Okay, technically I might have been born on the 21st in California, but when they look at my driver's license, it doesn't say a time. They're going to be really confused, like, why does California think your date of birth is April 21st when your date of birth is April 22nd? Like the concept of shifting times and dates around is really weird. So like dates are better if it's just a date, right? Because then you avoid all those sorts of issues. Time zones are just obnoxious to deal with. I hate dealing with time zones, and you have to do that in cloud-based applications that people all around the world can get at. Because if you're submitting data at your local time, I need to be converting that to whatever my time is, and I want to display it in your local time. And anyway, we don't want to get into that. So mammal. Here's our mammal class. So what things do mammals do then? So these are just attributes of mammals. So public what? Eat, did you say?
Yeah.
Eat? Okay.
You could have like a hunger status or something, and then you could like reduce hunger if you like.
We could definitely add stuff about hunger and reducing hunger. That feels complicated right now. How about eating just increases your weight in kilograms?
Yes.
Let's do that. So this is void eat, and that'll be a weight in kilograms should not be that's probably a double, not a string, right? I don't know why I had string there. So our weight in kilograms as a double, great. Do you guys want to close the doors, or it's a little noisy? Sorry. Eat for a double for, I don't know, food weight in kilograms. Sure. We'll go and eat. Okay. So we're going to take our weight in kilograms, and we're going to add the food weight in kilograms. Food weight. Okay, cool. No, I didn't add a constructor yet. We should do that. So I need a public mammal constructor. Yes, look at that. It suggested it all for me. I'm so happy. I don't like typing this stuff. That was really nice. So, and because our properties tend to have capital letters, right, but variable names have lowercase letters, we don't even need the this dot stuff, which is nice. We take all those, sure. So we got them. So we can eat to gain weight. So sure, we can do something. So we've got some way of doing this here. So we can interact with our mammal. We can create mammals. Now, we want to make a specific type of mammal here. Hector, my friend, thanks for donating those bits to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. We've made $3.50 towards the scholarship just tonight because we're here on Twitch. I know that isn't even a dent in anything, but exciting nonetheless. It adds up. It does add up. I was doing something, looking at different tuition rates. So one of the things I like to do is go promote community college, because I teach over at OCC. So I try and go around to high schools and be like, how much money do you want to spend? And we look at how much tuition costs. And there's a school down the road in Southfield, you might have heard of them, that charges $1,200, $1,279 per credit hour. I was just blown away. Like, I know things have gotten out of hand, but that's a lot per credit hour, right? It's insane. It just blows my mind. So like, I didn't even pay that much for grad school, and that's for undergrad. So anyway, back on top. So if we want to make a special type of mammal, so what is a mammal? A very specific mammal. Let's make a new class here. I'm fond of cats. I'm a cat person, so let's make a cat class. A public class. Cat. Now cat is a what? It is a mammal. Now, right off the bat, when I say cat is a mammal, right, this colon notation, what is my base class mammal? It yells at me and says, inconsistent accessibility. Oh, that's accessibility. That's fine. They gave me default internal. We'll just make this public. So internal is accessible to your package. public is accessible outside of the package or project. So if we make multiple projects in this solution, I wouldn't be able to get stuff that's marked as internal. For what we're doing now, it doesn't matter. We're really never going to get into multi-project stuff, but just keep that in your back pocket. If you want it to be used externally, it needs to be public so that you can use it outside of it. So if you're building something that's like a library for other classes to use, it should be public, not internal. Internal is fine for card because we're using card anywhere else, but that sort of thing. All right, so we took care of that one. Now, there's no argument given that corresponds to the required parameter species of mammal, string, double int. My superclass, my base class, has a constructor. You can't create a subclass, an instance of a subclass that doesn't call the superclass constructor, right? So what do we have to do? Well, we have to call mammal. So the first thing we do is we call our base class, and we give it all of those values. Now, I don't know what to give it here for some of these things. So like the potential fix here might be better. Let's generate the constructor. This is probably easier for us here. Oh my goodness, that was wrong. Nope. Did it do it? Holy cow, there it goes. Okay. This is really long, but that's okay. So the constructor here for cat will accept, now we don't need a species, right? Because they're all cats at this point. So I don't need an argument for species. So this is where I need to go in and do some modifications here. It's not, the default's not always right here. So I'm going to take out species, and then what I give my base class constructor, so colon, again, this colon notation to the base class constructor. Now, it's weird you don't say mammal, you say base, but sure. So here we say the name of the class, which makes sense because you have to tell it what it is here. But in the constructor, you just say base, and it knows it is of this type. So I don't give it species, I can just say cat. Or is that feline? Is feline the more proper term? I forget. What's that? That's cat species name. Oh my goodness. That's a lot of cats. I want house cat. Felius catus. Why can't I copy paste? There we go. Felius catus. Isn't that redundant? Yeah. Feline cat? Gorilla. Biology is fascinating. Super interesting field of study. So, all right, cool. But we still have a name, we still have a fur color, we still have a gender, we still have a weight, we still have an age. Sure. Now I can make a cat. Fantastic. So we're calling the base class constructor. Now, if your base class has a default constructor that takes no arguments, you don't have to call it because it will happen implicitly. Right? Same thing in C++, right? If your base class had a default constructor, it would get called automatically. Easy, right? You don't have to do it. But if there is no default constructor, I have to go call it because otherwise I can't be an instance, because what has to happen in the order of operations is the base class gets constructed first, its constructor runs, then the subclass, the derived class constructor can run. So this has to happen first. So we're inheriting everything. This is specific to calling the constructor, Fluffy. So because the mammal class has a constructor, a parameterized constructor, a constructor with parameters, a non-default constructor, whatever you want to call these things here, we have to call this one. There is no argument constructor, no default constructors. We have to be specific around what we're giving it here. Cat. Okay. Then, if you know anything about cats, you give them food, they're going to eat way too much of it and throw half of it up because I don't know why. So when cats eat, then we're going to have a public void override, or public override void eat. My goodness, eat. Where's my eat? Public void eat. Double food weight in kilograms. Why is it yelling me now? Can't override. Uh-oh, we're running into trouble here. I forgot a keyword, right? I said I want to override it, and it's telling me, no, you can't do that. It's not marked as overridable. I have to mark it as virtual or abstract, right? You ran into this back in C++, not surprised? It's been a while. It's okay. So just because I want to override it doesn't mean I can. So if you want something to be overrideable in the base class, we mark it as virtual. Say, okay, by the way, this might get overridden later. I'm okay with that. So if you don't add it, we're not going to override it later. Now I can go and override. So they come in pairs, right? So you will mark it virtual and override. Okay, so then when we eat, when our cat eats, then we're going to take our food weight in kilograms. Food. We'll just let's actually just do this. We'll say we want our base dot eat. So our base class eat food weight in kilograms times 0.75 because we're going to throw up 25% of it. Just sure. So you know, I've done a bad thing. I have a magic number here, a number in my code with no name here. So let's name this here. So this is my weight not eaten due to vomit, 0.75. Weight factor not eaten, something like that, right? Put a nice name to our variable here because that's a much better practice. So now you know what this is, right? Apologize for going this route. This was the first thing in my head, and I give my cats wet food at night because lots of reasons, and they're spoiled brats. And then one of the cats specifically eats way too much and then throws it up, and I'm mad at that cat. So that cat and I are fighting. I don't know how to make it not do it though. Just if you have cat tips, I would love to hear them because weight factor vomited. There we go. Weight factor just vomited. Okay, it's fine. We got some variable names. Cool. So we're going to do something special, but we still want to use that parent class method. We don't have to, right? Because we've marked these things as properties, they're public, we've got full access to them. And then we can go change these things. Maybe that's not proper. Maybe we don't want these things to be changeable directly here. So how about instead of making all these things settable, we just make them gets here, right? And all of this just kind of depends. I guess you can change the name of your pet. You probably can't change the species of your pet. I'm assuming mammals are pets here. Maybe that's a bad assumption, but could be, right? Your fur color, that can change, right? I think cats gray, other animals might gray, right? Just like humans. Gender is probably harder to change for pets. I feel like that's not a thing here. Okay, the weight here. Now, if we don't want weight to be set directly, if we want weight to be changed only by eating or defecating, we could add that in, right? They could lose weight that way, or exercise and they could burn some calories. We could have all sorts of cool formulas for how much do they run around. And you know, my Garmin watch loves to tell me how many calories I burned, but it never tells me how many pounds that is because you need to burn like 5,000 calories to burn a pound. And that's really depressing because you can't burn 5,000 calories like in a run unless you run for like 4 hours. So you know, I think they don't show that for a reason, but they like to show calories. Anyway, and then age, maybe age doesn't ever get set either. Age just increases and we have a public function. No, so it just depends. What do we want to be settable? What do we not want not to be settable? Settable, right? Changeable, that sort of thing. So, So by not including the set, it's saying it's read only. I can't change it. Remember, if we want things to be privately set, I need to say private set, right? Species, never going to change. We can just let it be read only, right? You set it once in the constructor, it's stuck. I don't need a private set because I'm never going to change the value of species here, right? Even in the rest of my code, that should be okay. So if I have private set access, I can do that. Now, with private set access in cat, I'm forced to use the eat method here because I don't have access to food weight in kilograms. Weight in kilograms equals something. I'm sorry, this is the, not food weight. Oh my goodness. Weight in kilograms. There we go. This is the mammal property, weight in kilograms. You said, hey, you can't do it because it's set accessor is inaccessible. It's marked as private. Right? If it's private, the only place you have access to it is in the class. But we have another level here. I don't remember if you got into this or not in your class here, but in between private and public is protected. Protected says, hey, my subclasses have access to this here. So if we know we're going to be inherited, we can mark this as protected and say, sure, my subclasses can have direct access, but publicly not. So it's that middle of the road accessibility part here. Please shout at me if you've done this before and it's boring. I know some of this is like repeat from other languages. So if you want, then we have access this way here. If not, you have to use the public method. I like the public method anyway, because sure, why not? It's kind of fun to do it that way. right, so we can inherit. Let's see, what else are we missing here then? Yeah, protected, sure. Make our drive class, objects. Why is my zoom all funny here? There we go. Base classes, sure. Instructors, yep, did that. That's fine. Casting, we'll talk more about this when we look at polymorphism for casting things as different types. That should be fine. We'll get to that. Protected. If you don't want someone to derive from your class, you can mark it as sealed. You are not allowed to extend or inherit from a sealed class. C# won't compile. There's all sorts of library classes in C# that are marked as sealed that upset me, because it'd be nice if I could do other fun stuff with them, but that's fine. So it's a thing you can do. Right? You got all sorts of access. Like if you don't want this method to be overridable, don't mark it virtual. If you don't want the class at all to be inheritable, I think that's a word, you mark it as sealed. So sealed's kind of a fun one. Okay, I got 8:30. Polymorphism would take a little bit longer. Is it okay if we call it an 8? Okay, so next week then we'll come back, we'll do polymorphism, we'll do interfaces. Structs and records are pretty quick. Generics will take not too much time for us. That should be okay because you've done generics before, those template types. And then we'll talk about the Yahtzee solution, and then we'll talk about the next project. We're going to be doing a poker game because poker is entertaining. Okay. All right. If you got questions, let me know. Please don't wait until next Thursday at 4 p.m. to come to the game lab and say, Eric, Yahtzee's not working. I need help. I'll do my best to help you, but let's try not to wait till then. So if you have questions, shoot them to me anytime. We can set up meetings. I can do Zoom. I can do Discord calls, screen shares. Other than that, like you don't have to wait till the post office hours, right? Please ask me beforehand. It'll be much easier. And then I think I've set up shared repositories for partners. I think there's one group I forgot that just emailed me. I'm just remembering now. So if you are working with a partner, just let me know if you want shared access. You don't have to. You're welcome to figure out yourselves and like email code back and forth, but that's the hard way. Totally up to you folks. All right. Thanks, everybody. Take care. A dad joke. All right, I got one dad joke then, as everyone shuffles out. You got it. Will.i.am, huh? All right, let's see. Let's see what we got here. Justice is a dish best served cold. If it were served warm, it would be just water. Oh, come on. That at least was a clever pun.
Well, I feel like it's better if you look at it instead of saying it.
Yeah. Here you go. That's true. Here you go. Can that readable here?
Oh, sure. There you go.
There we go. Boom.
That's gonna be the thumbnail.
I should do like actual thumbnails for my videos, but I just don't really care to.
You could always just put like the words of the subject